So tomorrow is going to be multiple choice, but you do have to write out like what you did. So for each question, you need to show your work. Like this is a formula that you used. Here's what you plugged in. Yeah, but it'll be multiple choice. So it'll be just like this. Same number of questions and everything. Very similar. So if you know how to do this whole thing, then you'll do fine on the class tomorrow. So let's go ahead and start with the first one. You're supposed to find if you invest $1,000, 7% compound annually after 11 years, how much money will you have? So in this first section, we're going to be using this value. This is our future value formula, right, that we use the most. So we're going to just start with our A, which is our future value. This is our present value of 1,000 times 1 plus our rate is 7%, 0.07. Now this is annually, so it's over 1, which means we don't even really need to write it. If it was like over 12 or something, we would, but we don't need to write over 1. And then it's to the n times, so 1 times 11, so 11 power. You do need to write this on the test. We're ready to write out the formula there. Write that out. So it'll be worth 2 points, writing it, and then plugging it in and getting the correct answer. Make sure you're trying some of these. Like, make sure you know how to type this in. Don't ask me tomorrow how to type it in. Make sure you know how to do this thing. After you type it in, you should get D. All right, next one. If you invest $480 at 7% compounded quarterly after a period of 9 years, it's going to be the same setup. A equals 480 and 1 plus our rate is 7%, so 0.07. This is quarterly, so over 4 to the n times t, so it's going to be 4 times 9, just 1d6. We'll then need to plug that in. Molly, can you go and move back to the other side? It'll still reach.
Okay. You're really? Okay.
Alright, so just plug it all in, and you should get C, 896.36.
So is this all the work we have to show?
For these, yeah, the first several are going to be pretty easy. Just, that's all the work that there is. Yep, plug in the right stuff. So easy. The first 10 questions are going to be basically plugging them in the right formula and then finding the answer. All right, number 3, Feldmans bought their first house for $19,000. Over the years, they moved 3 times into bigger and bigger houses. Now, 43 years later, they're ready to retire and want a smaller house like the one they first bought. If inflation in property values averaged 3.1% per year during that time, how much will such a house cost them now? So do we want to find a future value or a present value?
Future value. Present value.
Yeah.
So this is kind of a trick question. How much does it cost them now? But if we use a present value formula, it'd be like one of these, right? But this was supposed to be a future value here, right? Well, if we use this one, what's going to happen is, you plug it in, you're going to get a lower value because that's going to be a less. So this is actually, even though it's now, this is in the future, okay? Because this was the original amount. This is our sort of our principal, if you want to think of it that way. Our original, which was in the past, and then it's going to continue to inflate to the future. The future is now, though. Okay. So it's just, the future is now. So this was our original amount. We're still talking about a future value because this is how much it was, and then 43 years later gives us our future amount. So it's going to be A equals our present value, which was in the past, $19,000. 1 plus our inflation rate, property is 0.031. And this is per year, so it's going to be just over 1. You don't need to write anything per year. So the n times t, the n is 1, and the t is 43. So again, you just need to write it out, plug it in.
We rated it again.
And you should get $70,612. All right, number 4. We're going to invest $7,000 continuously. What is the balance after 2 years? So the keyword here is continuously, which means we're going to need to use, whenever you see that, you're going to want an E formula, right? The same formula in the future, except we're going to E, so it's A equals Hertz. A equals our present value of 7,000. E to the rate, which is 0.057, times our time of 2 years. And take a second and make sure you can type that in. It'll be parenthesis when you do your exponent, do times 2. And you should get C, 78.45. If you don't want to type it in, make sure you ask me today. Okay, the next one, we did a few problems on this, the effective rate of interest. So the formula for this one, definitely probably don't have this one memorized. But this R sub E, this means the effective rate. So all we have to do is plug it into these formulas and then compare the rates. Let's do that. We're going to be using this one. Effective rate means the annual rate. Just the equivalent of annual rate. So R sub E is going to be 1 plus, and then it's very similar to the interest formula. It's R over N to the N, but it doesn't have the T there. And that's minus 1. So it's going to be 0.08 over 1 plus would be 12 to the 12th power minus 1. Just show that you plugged it in. Make sure you use parentheses with that fraction inside of the parentheses. And you should get 0.08299. Rate's always got to be the decimal place though. So move it over 2 places. 8.29, which is 8.3.
How many questions are the next year involved effective rate?
Just the other 2. This one and the next one. Okay. But all you got to do is plug it in the formula. So this one's kind of like that bank question we did where we compared like Huntington, Park National, and PNC. Which of the 2 rates would yield the larger amounts in 1 year? 5% or 4.9%. So we're going to use the same effective rate formula. R sub E is 1 plus 5%, 0.05. Semi-annual is 2 to the 2nd power minus 1. And the other one is 4.9 compounded quarterly. So R sub E equals 1 plus 0.049. Quarterly is 4, and the 4th power minus 1. We're just going to compute both of those. This first one, you'll get 0.0506. So move 2 places, that'll be 5.06. And our next one we get 0.0499. Put it over two places, we get 4.99%. So which one do we want? A higher or a little lower? We want the higher one, right? Because we're talking about a yield. We want to yield a bigger amount. We're not paying it, so we want to, it's an investment. We want a good interest rate. So it's going to be that one, the first one. So that is the 5% compounded semi-annual rate. All right, number 7. This one says to find the present value. So present value, we want to use the formula that starts with a P. And the only thing different is that we switch the A and the P on these two, and then we also have a negative vector. If you prefer, you can also you can also write it as A over that value as well. So A over A over this. So as a fraction if you want to drop the negative. But I would just use this. So this is the present value. So let's try it here. So if we want to get 2,000 after 3 years, and it's compounded 6% semi-annually, basically how much do we need now? Our present value has to be 2,000 times 1 plus 0.06. Semi-annual is 2. To be 2 times 3, so it'll be 6. We need a negative up there. So we're going backwards. The negative makes it smaller. So if we want 2,000, we should start with the less, and that's going to be 1674.97. Next one, we want to get $10,000 after 2 years with 9% compounded monthly. So it's the same setup. 10,000 in the future. 1 plus 0.09. Monthly is 12. Go to 12 times 2. 24, so it'll be negative 24. Don't forget that negative, or else you'll get a bigger number. You'll probably get, if you forgot the negative, I'm guessing you would get that one. But we want a smaller number, 8358. Number 9 is also a present value. It says, what principal would we invest at 6% compounding continuously for 3 years that will yield us $1,500? How much do we need to invest now to have in 3 years we want $1,500? And it is continuous. Sometimes you see that you want an E. We want the one with the present value here. So it's going to be P equals A E to the negative RT. P equals our future value of 1,500. E to the negative R is 6. 6 times 3 years. So again, make sure you know how to type that in. You should get that 1252.91. All right, and last one, that's the last of the easy ones. Tracy bought a diamond ring appraised at $1,900 at an antique store. The diamonds have appreciated in value at an annual rate of 12%. What was the value of the ring 8 years ago? So we're going backwards. We want to know the present value. All right, so it's going to have a negative because it's going to take it less. So if it's 1,900 in the future, it's going to be our 1 plus, it's an annual rate, which means n is 1. That would be 0.12. n times t goes to 8 years, but it's in the past, so we get a negative at 8. If we're going backwards 8 years. And plug that in, we get your value 8 years ago, which was 767.38. Lots of these, yeah. Okay, now's where it gets a little bit more tricky. What annual rate of interest is required to double an investment in 6 years? So this time we're asking for an annual rate of interest R. Does anybody remember how we do this doubling? What we do? There's no number. There's like no number values, but just as an aside here, let's say we have $10, okay, and we want to double it in 6 years, so we want to end up with $20, right? And then we have all our interest rate stuff here. Okay. Our first step is going to be to divide, right? So we just end up with 2 equals the interest rate part. If it was $1,000, then it'd be the same. We'd start with 1,000, and then end up with 2,000. So we just divide our first step, right? We end up with just 2. So whenever you're doubling, you're just going to do 2 equals. It's going to be 2 times the amount, and then whatever the interest rate part is. So it's going to be 2 equals this part here. This is our interest rate part. So it's just going to be, like we're already divided, it's just going to be 2 equal to the interest rate. We'll have 2 equals 1 plus. Our rate we don't know, that's what we're trying to find. It is an annual rate, so that means n is 1. So it's like r over 1 or just r. For the n, which again is 1, times t. T is 6. So 2, because we're doubling it, equals our interest part. 1 plus r, 6. So now this is where we got to do some work. All the other ones, just plug them in, plug it into your calculator. What do we do to solve this? Yeah, the 6th root. We got a 6 power, so the opposite of that is a 6 root on both sides. The other thing to make sure you know how to plug in, 6 math x roots 2. You'll get a decimal there. Equals 1 plus r because the 6th power is canceled out. And then we just subtract 1, minus 1. And we get r equals 0.1224. It's a rate, so we need to move it over 2 places, 12.24%. So that one's going to be B. So from here on out, all of them are going to have some work you gotta do to solve it. You do need to show the work that you're doing for these. You can't just plug in the possibilities. You gotta show some work. All right. 12. How long does it take 1,700 to double if it's invested at 5% interest, compounded monthly, round to the nearest tenth? How long? So that means we're going to be finding a t. Does the 1,700, does that matter at all? It actually, this part just kind of, they're distracted. It doesn't matter. You could use it if you wanted to. You could say, well, 1,700 is going to double to then 3,400, right? But then you're just going to divide it and get 2 again. So it's still doubling time. So you don't need that 1,700, but if you did write it, double it with 34, you divide it, you get 2. It's going to be 2 because we're trying to double it. Equals 5% compounded monthly. So 1 plus our rate is 0.05. Monthly is 12. To be 12. T is what we're trying to find. So here's our setup. Okay, so now this one, what do we do to do this one? Do a 12th root? Yeah, this one's a natural log because the t is up in the exponent. If it was just a 12, we could do a 12th root, but this has a t. So we gotta do a natural log to do that. And then natural log allows us to take this and bring it down to 5. So then we have natural log of 2 equals 12t. Natural log of 1 plus 1.5. Alright, now what? Divide by that natural log, right? Cancel it out. I do that on both sides. And now we can go ahead and type in now. So we got natural log 2 divided by the other big natural log. And make sure you can type that in. Then with 12t equals 166.701, which still sort of compounding calculator, and then just hit divide by 12. Get and then t is 13.89. So 13.90. Another little thing you could do to check if you wanted to, you could probably actually use this to find the answer. You most likely would be right. But anybody remember that video we did that was called a rule of, remember? Yeah, 72, right? So the rule of 72 said that the doubling time is 72 divided by the interest rate. Okay. The interest rate has to be annual. So like this one, this is 5% interest. It's compounded monthly, but it's close to annual. Not quite. But if we did 72 divided by 5, we do that on a calculator, you'll get 14.4. So this one's just a little bit less. It's 13.9 because it's compounded monthly, so it's compounding more, so it'll take a little bit less time. But you get a good, rough estimate using this rule of 72 also. But you do need to show this work. You can't just use the rule of 72. And it would also work for that one up there. Or sorry, the next one will work because it's doubling time. So like on the next one, doubling time would be 72 divided by 5.5. And so we could compare this to what we get at the end. And this is an estimate, but that's 13.09. So we'll compare that to the end. But this one is compounded continuously, so it should take a little bit less time. So we got 7,000 rated 5.5 compounded continuously. Continuously means we're going to need the E formula. Alright, so we're going to have, we want the doubling time again. So the 7,000 actually doesn't matter, right? You could use the 7,000 and then you would have 14,000, but it doesn't matter. We're talking about doubling. So 2 equals. And then it's just going to be the E part, so the rate, which is 0.055 times E. So we got an E, which means we do natural log, right? E is natural log cancel. Natural log both sides. Natural log of 2 equals 0.055t. And then we just have to divide by that 0.055. So we said about 13 ends up being 12.6. And again, that's because it's compounded continuously rather than annually. So that shaved out 4 or 5. All right, let's look at the last page. This one's probably the most work. Number 14. Emory has $1,700 to invest at 7% per year compounded monthly. How long will it take before he has $2,100? And then there's another part of this question. We could answer it as well, but we'll actually get the answer with just the first part. So we're also supposed to say if it's continuous and how long will it be as well. Let's just try the first part. $700, we got to get up to 21. So we're just going to use our A equals P times 1 plus R over N T. We got 2,100 in the future. Now we've got 1,700 times 1 plus 7% compounded monthly would be 12. Would be 12 times T. We don't know T. How long? That means what's T? Okay, what's our first step in this one? Yep, we gotta divide. Get rid of this number first. In the doubling time, that's like already gone. Just divide 1,700 on both sides. And you can cancel out the zeros like I've been doing. So we get 21 over 17. Right, no. 1 plus 0.07 over 12. 12t. Okay, now what? 12th root or natural log? Yeah, since it has the t up there, we need a natural log. The 12th root will work because that we still have the t up there. Natural log both sides. That allows us to bring this down. So we got the natural log of 21 over 17 equals 12t. Natural log of 1 plus 0.07, 12. And once you do a few of these, you just get a sort of rhythm there. You then divide by the natural log. Both sides. So we'll type that in. It's a good idea to keep your fractions until you plug them in. And we get 12t equals 36.329. And then just keep it in there, divide by 12. And we get 3.0%. And the only one that has that in the answer is B. But if you did the same for continuous, you would get the other one, 3.019. Three more. How long? So it's another t to grow 3,400 to 20,900. The interest rate's 10.7%, compounded continuously. That means we're going to be looking at our E formulas, right? So our future value is 20,900. Currently, we've got 3,400. E to the rate there is going to be 0.107 times E. So as always, the first thing we'll do is divide. 3,400. Divide by our zeros. 209 over 34 equals E to the 0.107. Since we got E, the opposite of that's natural log. And 1 wipes it out. That's the natural log of that divided by 0.107. should have 1.815 equals 0.107p. And then when we divide, we get 16.9. Right. And that's the most obvious answer, you know. Hopefully it wouldn't take almost 1,700 years. Well, too long. Live, 10 lifetimes. 17 lifetimes plus. Jesus, buddy. All right, two more. Randy is going to invest his inheritance of $15,000 in the account that pays interest come monthly. When he was ready to retire 15 years later, he found that he now had $150,000. What rate of interest did he earn? Right. So same setup here. We've got our future, we got our current or present value, times the past. 150 equals 15,000 times 1 plus R over 12, because it's monthly. 12 times 50. Yeah, they're all good, huh? Good. So we'll divide both sides first. We divide them by some zeros. And 150 divided by 15 is actually just 10. So 10 equals 1 plus R over 12. And then 12 times 15, 150. This one does not have a variable in the exponent, which means we'll do the root 1 for this one. So we want to do the 180th root. Okay. So 180 x root of 10. Keep it in your calculator. With 1 plus R of 12. We then subtract the 1 first and multiply by 12. So R to be 0.15449. Two places, 15 point. Now this one's tricky. Rounding to the nearest tenth. Is it 15.4 or 15.5? So we'll move it over to here. And this is the tenth place, so we look next to it is 4, so we keep it the same. So let me see how good you are rounding. This round up the next one to 4 or 5. But someone tried to argue that if you round this one rounds up to a 5, and then so that changes that one to round up. That's not how rounding works, kind of like a domino effect. Alright, so that is B. And the last one, got our green investor here, Carl. He has invested his allowance savings of $40 in an account that paid interest compounded continuously. When he was ready to retire 60 years later, he found that he now had $10,000. What rate of interest did he earn? I think it's 92%. Alright, so in the future, 60 years later, he's got 10 grand. Start with the near 40 to $40. It is continuous, so we're going to do our E. Our R we don't know. Time is 60. So 60 R. So we'll do 1,000 divided by 40. got then 1,000 divided by 4, which is actually just 250. Equals e to the 60r. And we then want to natural log it. Wipes it out. Natural log of 250. 5.521 60r. And then divide by 60. R is 0.092. Two places, and then it's actually just 9.2%. Pretty surprising, huh? Invest $40, you get $10,000. It's obviously a long time, but the power of compound interest.